Okay, this is on the physics review for the Newton's test. A lot of this is going back and using information about motion and projectiles and applying it with our new Newton's information and tension and things like that. So let's start with number 1 on the review, where it says that a car is traveling 35 meters per second when he notices a stop sign 250 meters away. So we know the initial speed is 35 meters per second. And then it says that he slams on his brake and comes to a rest. So that would mean his final speed is 0 meters per second. And he does this in a distance of 250 meters. What is the negative acceleration of the car? So they want us to find A. Well, to find A, we're going to have to use the formula VF squared equals V naught squared plus 2AD. The reason we can't use the normal acceleration formula is because we don't have any time, and we wouldn't be able to find time. So we're going to go ahead and plug this in. If we know 0 squared equals 35 squared plus 2 times 250A, and we're solving for A. So we take our negative 35 squared equals 500a, divide by 500 on both sides to isolate your variable, and you should be able to find out that a equals a negative 2.45 meters per second squared. So that's your first answer on that first question, so that's A. And then for B, they tell you that the mass of the car is 1,000 kilograms, and they want to know how much force it's going to take, which would be mass times acceleration. Well, that would mean you take your 1,000 times your negative 2.45 meters per second squared. This was your kilograms. And you should end up with an answer of a negative 2,450 newtons. And that would be your braking force, which it is negative because of the fact that it's going against your forward motion. All right, moving on. Number 2. What is the weight of a book that has a mass? So they give us mass to be 1.68 kilograms while resting on planet Earth. So we just want to know the weight, which is weight force, is mass times gravity. And we know gravity on Earth to be 10 meters per second squared. So we're going to take 1.68 times 10, which is going to give me 16.8 newtons. So that's going to be my weight on Earth. It then tells me what would be the weight of the book on the moon, if gravity on the moon were 1.63 meters per second squared. Well, then we use the same formula, but instead we're going to take the mass of 1.68 and multiply by the gravity on the moon, which is 1.63. And when we get that answer, we should be able to calculate it out to be, oh, hold on, what was it asking me? Yeah, what was the weight on the moon? Sorry, that should be 2.74 newtons. And so that's your B. And then C asks me, oh, it doesn't ask me. Oh, second question. I didn't really answer those in order, did I? Sorry, I wasn't reading. If we moved the book to the moon, what would be the mass of the book? Well, the key to that is that mass stays the same, regardless of location. Ooh, not writing very well today. Sorry, guys. Okay, so your first answer was this one up here in blue. Your second answer to this question was right here in black. And your third part of this question was in red. All right, moving on. Okay, number 3. Number 3 is asking us a box. Ooh, you gotta like the boxes. A box is pushed along a floor with a constant velocity of, since it's pushed, I'm just going to draw it this way, 125 newtons, yes? Yes. How much frictional force exists between the floor in the box is what it should say. All right. Well, the thing to realize on this problem is it says constant speed or velocity. Velocity. I do know how to spell the word. All right. Since it's constant, that means that there's balanced forces. So if it's 125 newtons forward, then the answer would have to be a negative 125 newtons or 125 newtons backwards. So it's just the opposite, the same amount, but the opposite direction. Number 4. Calculate the acceleration of a 100 kilogram cart when a force of 600 newtons is applied to the right and the surface of contact is frictionless. Okay, so we've got our nice little cart, and I'm going to put it on wheels. Woo-hoo. And it's going to be going on our surface, and it's moving towards the right with 600 newtons of force applied, and we know the mass to be 100 kilograms, so we want to say F equals ma. So 600 newtons divided by my 100 kilograms would give me an acceleration of 6 meters per second squared. Easy, easy, easy. Number 5, we have the lovely child being pushed in a wagon. So let's draw our wagon. And they're being pushed, so I'm going to go to the right with the force. This is 125 kilogram mass, and the force is 450 newtons. What is the acceleration of the wagon is part A. So A is force equals mass times acceleration. So we're going to take 450, divide it by 125, and we're going to get an answer of number 4. Is that what problem I'm on? I keep track of my stuff, don't I? Nope, we're at number 5. Sorry. Number 5 should be 3.6 meters per second squared. Okay, when you do that calculation. Then we are asked if the acceleration lasts for 10 seconds. So for B, we now know the time to be 10 seconds. And we initially started at rest, so 0 meters per second. How far did it travel? We want to solve for D. We have a formula that says D equals V naught T plus 1/2 AT squared. So to solve for D, we would say 0 times 10 seconds, which you can cancel out, plus 1/2 times 3.6 times 10 squared. And when you do the calculation out for that problem, you should get 180 meters. All right, for part C on this problem, they want to know what's the final speed of the wagon at the end of the 10 seconds. So they want you to find VF now. Well, if you are going to solve for VF, you can do VF squared equals V naught squared plus 2AD again, because we can use our distance information. We could also do our VF equals V naught plus AT. Either way, it's going to work. So if we say our VF equals 0, I like this one better, it's easier, plus 3.6 times my 10, then my speed should be 36 meters per second at the end of 10 seconds. So that would be your A, B, and C answers. All right, moving on. Number 6, Rose is gonna sled down the slide. Oh, fun, I like these problems. Okay, we've got Rose and her sled. Woohoo, Rose. All right, and the incline here is 25 degrees. And we are told that the sled and the mass the combined mass is 54 kilograms. What is the force pulling them down the hill? So we are looking for this force, the directional force. So, things we know. This force is mg. It's gravitational force. So my blue force is going to end up calculating out to be 54 times 10, which is going to give me 540 newtons. All right, so this is 540 newtons, and that's a bad 540 newtons. All right, then we also are going to know that this is the normal force. Since this is the normal force, that also means that I have force this direction. Notice I've labeled these the same color so that you would realize that the directional force can be figured this way. Now, we separated our gravitational and our normal force by 25 degrees. So if that's the case, we can find our FD because our FD is the, let me pick a different color. Let's do red. FD is the opposite from our angle, whereas the 540 or the mg is our hypotenuse. Opposite and hypotenuse are sine. So sine of our angle equals opposite over hypotenuse. So we're going to fill in what we know. Sine of 25 equals our opposite, which we call FD, divided by our hypotenuse, which is 540. So we're going to take this and cross multiply. And when you cross multiply on number 6, you should get an answer of 228.21 newtons. Now remember, this FD can also be labeled WX or F of X. It can have all different little sets of information on it because it's really just a component of your gravitational force. So don't flip out if you see it a different way. They can be done this way all the time. All right, moving on. Number 7. Number 7 says a child loves to slide across a very waxy living room floor in his socks. And the child has a weight, so that is a force. So we can say weight, or we can say FW, or we can say FG. All of those would be true, and that is 225 newtons. Now, since it is a flat floor, this is also equal to our normal force because we have kid sliding across floor. Okay, and this would be their gravitational and normal force. So those are the same direction. The coefficient, which is mu, in a sliding force is 0.125. And they want us to find our frictional force. So they want us to find, and let's make that F, they want us to find this force. Okay, so the formula for that is mu times F of n, which we can say 0.125 times our 225, which would give me an answer on number 7 as 28.13 newtons. And that's our frictional force. All right. Number 8. Number 8. A picture with a mass of, okay, we've got our lovely little picture here. And we know that it's downward. We know its mass is going to be 8.6 kilograms. So we know this mg to be 86 newtons. Hangs from a nail on the wall. Determine the tension in each side. So we are going to say that we have here, and we want to find the force of tension here. Well, you need to remember that this gravitational force can be applied along this triangle all the way here. And if it shows in our diagram that the angle at the top between the blue right here is a 90-degree angle. If that's a 90-degree angle, then that makes this angle a 45 right here. Makes each one, if you bisect it, a 45. All right. So if that's the case, we now know that our mg is 86. So we could draw this triangle. I'm going to draw it over here to look like this, where we have 86 newtons, and we have our ft over here. Now, We're just dealing with half of it. So instead of dealing with 86, let's go ahead and divide this by 2, and let's deal with 43 newtons instead. Okay, so our black is going to be 43 newtons because we're only dealing with half the triangle. I'm only going to deal with this part of it. Okay, if that's the case, and I know that the angle up here is 45 degrees, I can say that this side is my adjacent and this side is my hypotenuse. Adjacent and hypotenuse is cosine of angle equals adjacent divided by hypotenuse. So the cosine of 45 degrees equals my adjacent of 43 divided by my FT. Now realize that these two can just switch positions. So FT equals 43 newtons divided by the cosine of 45 degrees. And when you do your calculations properly in your calculator, you should find out that it's 60.81 newtons. And that would be your information. That's your tension. So that would be your force in blue. That's our force, our tension force. All right, let's move on. Number 9. Number 9, spinner and exhausted gymnast hangs her, and that should be from a bar, not a burr. Okay, sorry, typo, guys. She hangs from a bar by both arms. So here she is, crazy little girl that she is. All right, she's hanging from a bar, and she has a mass of 72.4 kilograms. So her mg pulling down should be 724 newtons because we took gravity, 10 meters per second squared, and multiplied with 2. What's the tension in each one? Okay, as he hangs in place. So again, the arms are pulling up if gravity is pulling down. So we just take this and divide it by 2, and we should have that each arm is holding 362 newtons worth of tension to hold up that much force. All right. Number 10. Number 10 is our lovely projectile review problem. Golf ball is hit at an angle of 18 degrees to the horizontal with a speed of 45 meters per second. We want to first find the Vx. Vx equals, okay, well, that means I want to find this down here. So Vx is my adjacent, so I'm going to say cosine of 18 times my 45 should give me an answer of 42.80 meters per second. So there's my answer for A. We then want to solve for the Vy. And it says on here that they want you to solve for the initial Vy. Well, remember that initial can be here or it could be your final, depending on whether you want to talk about beginning or ending trip. The Vy period is the velocity that you're going to go up or down with. So we're going to take the sine of 18 times 45, and we're going to get the answer of 13.91 meters per second. Okay, so that is B. Now, the next one, they want us to find how high it went. So they want us to find the dy. Okay, well, I like to talk about the downward trip, so I like to talk about this way instead, which means my gravity gets to be a positive 10 meters per second squared. And it means that my initial speed is going to be 0 at the top here. And that means my final speed will be whatever my Vy was, is 13.91. Okay, if that's the case, then to find my dy, I'm going to use my um, formula that's VF squared equals V naught squared plus 2AD, because I can solve for D. I have everything else because I can plug G in for A. So if that's the case, I want to take my VF squared minus my V naught squared divided by 2G. So I'm going to say 13.91 squared minus 0 squared over 2 times 10, which is going to give me an answer of 9.67 meters. So this would be my answer to C. And I use this because, again, I don't have time yet. And since I don't have time, I can just use this formula because I have gravity. And it could have been that you switched these two and made this a negative number. That would have worked too. Whichever way floats your boat, it will work. But you just have to make sure that you make them correspond, that if you use a negative 10, then your beginning speed is your 13.91. If you use a positive 10, your beginning speed or beginning velocity is 0. All right. So for D on this problem, they want us to find the time that it was in the air. So they want us to find the hang time. Well, we can find a time for here and a time for here. So if that's the case, we can say T equals, and we know the initial speed, okay, we know the final speed, minus the initial speed, and we can divide it by A, or G in our case. So if we take our final speed of 13.91, subtract 0, divided by 10, we should be able to find out that it was in the air for 1.39 seconds. We want to find the hang time, which means the up and the down. So I have to multiply this by 2, and I get my answer of 2.78 seconds was how long it was in the air. And that would be D, or our hang time. Then for E, they want to know how far it travels, so they want our dx. To solve for dx, we can only use one formula, which is Vx times t. They want our capital T, which means they want our up and down time. So they want our hang time. So we're going to use this time of 2.78. We're going to look up and find out what we found for Vx, which was 42.80. And when we multiply the two of those together, we're going to get that it went a distance of 118.98 meters. So that would be your total distance, and that would be your answer to E. You need to make sure that you realize how to work through a problem like this. My main thing to remember to tell you is that once you've used this 45 right here at the beginning of the problem, never, ever, 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 ever use it again. Okay? After you use it for the 45 at the beginning, don't use it again. You'll use it to find this one right here, your Vx and your Vy, but after you use that, don't plug it in as a number anywhere else. So don't, for C, for D, and for E, don't plug 45 in anywhere. All right? Moving on, number 11. A can is kicked horizontally. Okay, so we got a can on a cliff, and it's kicked horizontally, which is going to be our Vx. And since it's kicked horizontally with 8.5 meters per second, all right, the cliff is 4.9 meters high. And we want to know its time in the air, because it's going to go do, 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 do. And we want to know its distance. So we want to know our dx from the edge of the cliff, or its range. So to solve for time, time is going to go with the information. First of all, let me go over here and do my xy's. I know that the initial speed is 0 meters per second because it's falling off a cliff. I know gravity is going to interact with it 10 meters per second squared. And I know that the initial speed in the x is, or the only speed in the x is 8.5 meters per second. and I know the dy is going to be 4.9 meters. So I'm going to use the formula T equals the square root of 2dy divided by g. So if that's the case, 2 times 4.9 divided by 10, take the square root. And time is going to end up being calculated to be 0.99 seconds. All right, that's the time here, but that's also the time here because it's just a one-way problem. It's just going down. So if we now know this velocity and the time, we can find dx, because again, the only formula you're allowed to use in the x is this one. And so we can say 8.5 times 0.99, and that's going to give us a range of 8.42 meters. And that would be your answer. All right. Number 12, we're almost done. Number 12, a refrigerator weighs, so this is a force, 100,000 newtons, and it takes another force of 450 newtons to set the refrigerator in motion. What is the coefficient of friction between the floor and the refrigerator? Okay, well, we know since this is, if it's going to be set in motion, we at least had to overcome this frictional force because we have our refrigerator and we have it here and we want to put it in motion. So it takes 450 newtons to do that. And to at least get it to move, we have to have at least that much force to overcome the frictional force. Now, it does tell you that's its weight, so that is coming downwards, the 1,000 newtons is. And if that's coming downwards, that's also the same as the upwards, so that's the normal force also. They want us to find the coefficient of friction between the two. So frictional force is mu times the normal force. So 450 divided by 100 or 1,000, equals mu. So mu would equal 0.45. Now notice mu has no units because this was newtons and this was newtons and they cancel out. All right. And finally, number 13. Let's talk about number 13. Number 13 is a very fun problem because it's talking about a wire that is 5 meters long and it's strung between two trees, tree 1 and tree 2. Okay, and we're going to hang a bird feeder on it and we're going to hang it in the middle. All right, so I have my little bird feeder house thing. Okay, now when I do that, it's going to sag down. And we are told that it sags down a distance of 10 centimeters. Well, the thing to realize is if I hang this in the middle, I now have created this to be 2.5 meters on this side. And I have to convert this from 10 centimeters to meters, which I divide by 100 and I get 0.1 meters. All right. We all okay with that so far, hopefully. Then I'm going to also be able to say that there's a mass of 2.8 kilograms and the gravity is 10 meters per second squared for this problem. So I could say that my weight force or my gravitational force or just my weight or whatever you want to call it, your mg, would equal 28 newtons because I'm going to multiply it together. So that's going to be the downwards force. All right. Well, with having both of these distances, I can find my angle that this rope sags by taking the inverse tangent of my opposite, which is 0.1, divided by my adjacent, which is 2.5. I could end up finding the angle. The angle would end up calculating out to be 2.29 degrees. And that's a little one because you have to remember it is just a rope sagging. Okay. Now this is going to get used because we can redraw this triangle over here and we can say that this is that downward force. But remember, we're only talking about half of this. So we're going to take 28 and divide it by 2, which is going to give me 14 newtons, right? So this is going to be 14 newtons on this side. All right, it's gravity pulling down. And I now know this angle to be 2.29 degrees. They want me to find the tension in this rope. So to find that tension, that is going to be sine is going to of 2.29 degrees equals my opposite, which is 14 newtons, divided by my hypotenuse, which is my tension. Remember, you can just switch places with these two. So 14 newtons divided by the sine of 2.29 degrees equals your Ft then. And you should be able to find out that your tension force is 350.28 newtons. Now, my other comment would be is that, no, that's the best way to do it because we don't have any other forces. So to find the tension in the wire would be that on each side. Okay, so that would be your answer. Hopefully this helps. Take your time, pause, rewind, do what you need to do, but be ready for your exam on Wednesday and Thursday. All right, check you later. Bye.